Hi there, I'm your math help tutor, and today we are going to learn about addition and subtraction of numbers using the standard algorithm. There are several ways for us to visualize what happens to numbers when we add them to or subtract them from other numbers. We can use blocks, number lines, decomposition, and the standard algorithm. In this video, we will discuss adding and subtracting numbers using the standard algorithm, which is one of the most common ways of adding and subtracting big numbers. Adding and subtracting numbers using blocks, the number line, and decomposition are great ways for us to understand what happens during addition and subtraction, which may not be obvious when we only know how to use the standard algorithm. The other ways of adding and subtracting numbers are well and good until we have to work on larger numbers. Say we want to add 40,571 and 14,216. If we use blocks, whoa, that's going to require us to have or draw a lot of blocks. So let's try to draw 40,571 blocks. Let's try drawing 40,571 blocks. I mean, let's not even try to do it. That's just so much number of blocks, right? Now, if we use the number line, it's also going to take us some time when we keep on jumping by thousands and hundreds and tens and then adding them all up just to perform this operation. So let's say we have 40,571 on the number line, and then what we do is we're going to jump by 10,000 plus 10,000, and then we're going to jump by another 4,000. This 10,000 is 4,000, and then we're going to jump by 200, and then jump by 10, and then jump by 6, and then do the addition, 50,571, and then we add 4,000 to it, that would be 54,571, and then we add plus 200, so at this point it's going to be 54,771, and then at this point we're going to add 10, that's 54,781, and then at this point we add an additional 6, so that's 54,787. As for decomposition, it's faster than the two other methods I mentioned, but it's still going to take a longer time. However, if we want to add or subtract quickly, we can just use the technique called the standard algorithm. Let's try to use the standard algorithm to add the numbers 40,571 and 14,216. The standard algorithm is actually a shortened form of the decomposition method, and we will still do some carrying over or borrowing, but in a faster way. Let's do the decomposition method first, and then let's try the standard algorithm beside it. So here, let's do the decomposition method, and then here we use the standard algorithm. So for the decomposition method, first we write the numbers in their decomposed forms. So we have 40,000 plus 0. Okay, 40,000 is the 10,000s place. 0 is the 1,000s place. Plus the hundreds place is 500, plus the tens place 70, plus 1, the ones place. And we are going to add 14,216. So let's write the decomposed form. It's 10,000 for the 10,000s place, and then we have 4,000 for the thousands place, and then we have 200 for the hundreds place, and then we have 10 for the tens place, and then 6 for the ones place. After that, we do the addition starting from the rightmost place. So 6 plus 1 is 7, 70 plus 10 is 80, plus 500 plus 200 is 700, plus 0 plus 4,000 is 4,000, and 40,000 plus 10,000 is 50,000. So adding all these numbers up, we get 54,787. And that's by using the decomposition method. When we use the standard algorithm, this is understood already, and there's no need to decompose all the different digits and places. It is assumed that you understand that this is a shortcut of the decomposition method. So to use the standard algorithm, what we do is we write the numbers that we are adding. That's 40,571. And then under it, we write the other number. That's 14,216. Put a line under the second number. And then we do addition per digit beginning from the rightmost place. So 6 plus 1 is 7, 7 plus 1 is 8, 5 plus 2 is 7, we put a comma here, 0 plus 4 is 4, and 4 plus 1 is 5, which gives us 54,787. So there we have it. Very quick and easy, right? You can see that the standard algorithm is a lot faster as compared to the decomposition method. Let's try another example, this time with carrying over. Let's add 78,256 and 12,459. I'll show you the decomposition method first, and then we do the standard algorithm beside it so you can see what's happening. So let's do the decomposition method first. Let's decompose the first number. That's 70,000 plus 8,000 plus 200 plus 50 plus 6. And then we add the next number, which is 12,459. That's 10,000 plus 2,000 plus 400 plus 50 plus 9. And then let's put an underline here to separate our numbers from the answer. So what we do is we add the numbers beginning with the rightmost place. So 9 plus 6 is 15. However, remember the rule that for every place, the maximum digit allowed is 9. Since the result of the addition of each of these places is going to result in the digits of our new number, that means 15 cannot be a digit for our ones place for the new number. So what we have to do is, remembering the rule that whenever we exceed the digit 9, we have to transfer the excess amount to the place to the left. And what is 15? 15 is actually 10 plus 5. So 5 we can retain in the ones place, and 10 we have to add to the tens place. So let's put 10 over here. And this is what we call carrying over. So let's retain 5 over here, and we have 10 over here. Now we can proceed with the addition of the tens place. So 50 plus 50 is 100, but we have a 10 over here that's carried over from the ones place. So 50 plus 50 plus 10 gives us 110. But again, this is not possible because the maximum value that the tens place can have is 90. And we cannot have a value of 110 in our tens place. The only values allowed here would be from 0 to 90, or the only digits allowed would be from 0 to 9. So what we do with the excess is to transfer the excess and carry it over to the hundreds place. So 110 is actually 100 plus 10. So 100 we carry over to the hundreds place, and we just retain 10. So we still have 110, but now we have decomposed the answer and transferred the excess to the next place. We just put a plus here, and we'll proceed with the addition of the hundreds place. So 400 plus 200 plus 100 is 700. So since this does not exceed 900, we're not going to do any carrying over. Put a plus 1 here, and then let's proceed with adding the thousands place. So 8,000 plus 2,000 is 10,000. Again, this is not possible because the maximum value allowed in the thousands place is 9,000. And since 10,000 is in excess of the maximum value here for the thousands place, this is not acceptable, and we have to carry over the excess amount to the 10,000s place. So if we decompose 10,000, that's 10,000 plus 0 thousands. We carry over the excess, which is 10,000, and we just retain 0 in the thousands place. And then we put a plus here, and then we proceed with the addition. So this is 70,000 plus 10,000 plus another 10,000 gives us 90,000. Adding all these numbers up, it gives us the answer, which is 90,000. It's 90,715. Now let's try doing the same addition operation, but this time using the standard algorithm. So we have 78,256 plus 12,459. Let's put an underline here to separate the numbers from the answer. So in doing the standard algorithm, we just add the individual digits beginning from the ones place moving to the left. So what's 9 plus 6? 9 plus 6 is 15. But again, the maximum digit that we can have for our number is just 9. So we have an excess. So our answer exceeds the maximum digit allowed. So what we do is we just retain the first digit, that's 5, and then we carry over the 1. So it's the same thing. We just carried over the 10 over here in the decomposition method. But here, instead of writing 15 15, we just carry over the 1 on top of the tens place digits. Next, let's do 5 plus 5. That's 10 plus 1, that's 11. Instead of writing 11 here, which is not allowed because the maximum digit we can have for our final answer is 9. So we put the digit to the left on top of the hundreds place, which is actually this one. We're carrying over 100. Next, let's do 4 plus 2 in the hundreds place. 4 plus 2 is 6 plus the carried over 1, so that's 7. Since we did not exceed the maximum digit 9, we are not going to carry over anything. Let's put a comma here to separate the thousands. And then we do 8 plus 2 of the thousands place. 8 plus 2 is 10. But again, 10 exceeds the maximum digit of 9, so we carry over the 1 on top of the 10,000s place digits. And that's actually this one. And then we add 7 plus 1, that's 8 plus 1 that's carried over, that's 9. And there we have it. We have our final answer using the standard algorithm, which is very quick and easy. And we don't have to write so many numbers as compared to the decomposition method. Now let's try subtracting using the standard algorithm. Again, I'll show you first the expanded form so you see what is actually happening when we subtract numbers. And then I'll show you the quicker and easier method, which is the standard algorithm. So let's subtract 8,288 from 14,191. So let's have the decomposition method over here, and let's have the standard algorithm over here. Let's first write the expanded form of our first number. That's 10,000 plus 4,000 plus 100 plus 90 plus 1. And then we are going to subtract 8,280 and 8. So we don't have a 10,000s place, so we just put 0 over here. And then let's put an underline under the second numbers expanded form to separate our numbers from the answer. Next, let's do the subtraction beginning from the rightmost place, beginning from the ones place. So let's have 1 minus 8. You can see here that this subtraction is not possible because we cannot subtract 8 from 1 because 8 is a lot larger than 1. So what do we do since we can't perform that subtraction operation? And that not only happens for the ones place, it also happens for the hundreds place where we can't subtract 200 from 100, and also in the thousands place because we can't subtract 8,000 from 4,000. So what we're going to do is to borrow. We're going to borrow from the place to the left in order for us to be able to perform the subtraction operation. So since we can't take away 8 from 1, what we're going to do is we are going to borrow from the place to the left. So let's borrow 10 from the place to the left. So if we borrow 10, this becomes a new number. It becomes 80, and we put the 10 that we have borrowed in the ones place. So 10 plus 1 becomes 11. Okay, so we borrowed 10, we transferred 10 to the ones place. So that's 1 plus 10, it becomes 11. Now we can perform the subtraction. So 11 minus 8 is 3. Now moving on to the tens place, let's put a plus sign here. Now moving on to the tens place, we have 80 minus 80, which is 0. Let's put an addition sign here and then move on to the hundreds place. Now can we take away 200 from 100? It's not possible, right? Because 200 is larger than 100. So again, we are going to borrow from the place to the left. So we are going to borrow 1,000. Let's transfer 1,000 from the thousands place to the hundreds place. So 100 plus 1,000 becomes 1,100. And 4,000, since we took away 1,000 from it, becomes a new number. It becomes 3,000. Now we can perform the subtraction in the hundreds place. And what is 1,100 minus 200? That will be 900. Okay, let's put a plus sign over here and then proceed with subtracting in the thousands place. Next is 3,000 minus 8,000, which is not possible because 8,000 is a lot larger than 3,000. So we can't take away 8,000 from 3,000. So again, we are going to borrow from the place to the left so that we can make this subtraction possible. What we're going to do is we're going to borrow 10,000. So we move 10,000 from here to here. So 3,000 becomes a new number. So 3,000 plus 10,000 becomes 13,000. Let's just put a 1 over here. Since we added 10,000 to 3,000, that becomes 13,000. And 10,000 minus 10,000, since we transferred the 10,000 to the thousands place, this now becomes 0. So now we can perform the subtraction in the thousands place. And 13,000 minus 8,000 becomes 5,000. Okay, and then let's put a plus sign here and then move on to the 10,000s place. So what's left is 0 minus 0, which is 0. So adding all these numbers up, we get our answer, which is 5,903. Now let's do this subtraction using the standard algorithm. So let's have 14,191, and then put a minus sign here, and we are going to subtract 8,288 and put an underline after the second number so we can separate our numbers from our answer. Now, since there is no 10,000s place, this is understood to be 0. You can put a 0 here so that you're not confused, but normally we just don't add any digits if there are missing digits to the left. So, using the standard algorithm to subtract these two numbers, we're going to subtract the digits only, and we're going to start from the ones place, moving to the left. So 1 minus 8 is, again, not possible, right? So what we do is we just borrow 1 from the tens place. So 9 minus 1 becomes 8. And we just transfer that 1 to the ones place. So this becomes 11. And that's actually what's happening here, right, in the decomposition method. So now we can perform 8 minus 11, which is 3. And then moving on, let's have 8 minus 8, which is 0. No need to borrow or carry over because this subtraction is possible. Moving on to the hundreds place, let's have 1 minus 2, which is not possible. So what we do is we are going to borrow 1 from the thousands place, wherein 4 minus 1 becomes 3. And we're going to add that 1 beside this digit. So this becomes 11. Cross this out. So now we can have 11 minus 2, which is 9. Okay, let's put a comma here and then proceed with subtraction of the thousands place. So we have 3 minus 8, which again is not possible because 8 is larger than 3. So we borrow from the next place, which is 1. So 1 minus 1 becomes 0. And then our 3, what we do is we put a 1 beside our 3. This becomes 13. So we can now perform 13 minus 8, which gives us 5. And there we have it. We have our answer, which is the same as what we got from the decomposition method. And you can see all the borrowing of numbers on top of our standard algorithm is very much the same as that in the decomposition method. Let's now try a few more examples using just the standard algorithm. Let's add 3,255,671 and 2,975,411. So again, using the standard algorithm, we are going to add each digit beginning from the ones place, and then we continue adding our digits moving to the left. So let's start with 1 plus 1, that's 2. Next, let's have 7 plus 1, that's 8. 6 plus 4 is 10, but since the maximum amount of the digit that we can have is 9, so 10 is an excess, what we do is we just put the first digit here and then the second digit here. Let's put a comma. Next, let's do 5 plus 5, that's 10, but there's an extra 1 here. Okay, so we add that to 10. 5 plus 5 is 10 plus 1, that's 11. Again, 11 is not allowed because the maximum digit we can have is 9. So we transfer or we carry over the 1 to the next place to the left. Next, let's have 7 plus 5, that's 12, but we have a 1 here, so that's plus 1. 12 plus 1 is 13. Again, we have an excess, so we transfer that, carry over that 1 over here. And then we do 9 plus 2, which is 11. And then we add the 1 that was carried over, it's 12. And again, we have an excess, so we transfer over that 1 over here. And then we proceed with the addition. That's 3 plus 2, 5 plus 1, which was carried over. So that is 6. And then let's put a comma. So there's our answer. Very quick and easy. Our answer is 6,231,082. Let's now try subtraction using the standard algorithm. Let's have 10,475,608 minus 8,294,819. So again, with standard algorithm, we are going to subtract each digit beginning from the rightmost place, which is the ones place, and then we keep on subtracting our digits moving to the left. So first, let's have 8 minus 9, which is not possible, right? So since that is not possible, because 9 is bigger than 8, we're going to borrow from the next digit. But the next digit, the tens place, can't lend us anything, right? Because it's 0. So the tens digit is going to borrow first from the hundreds place. Let's borrow 1 from the hundreds place. That's 5. And then we transfer that 1 to the tens place, which makes it into 10. And then we proceed with borrowing 1 from the tens place to the ones place. So this becomes 9. And our 8 becomes 18. So now we can perform 18 minus 9, which is 9. And we can also perform 9 minus 1, which is 8. Next, in the hundreds place, we can't do 5 minus 8 because 8 is larger than 5. So what do? We borrow 1 from the thousands place. So 5 becomes 4. And then we add 1 to the hundreds place, making 5 into 15. So now we can do 15 minus 8, which is 7. Let's put a comma over here. And then we proceed to subtracting the thousands place. 4 minus 4 is 0. 7 minus 9 is not possible, so we borrow from the next place. 4 becomes 3. And then we add the digit 1 to the left of the digit 7. So 7 becomes 17. So 17 minus 9 is 8. Next, let's do 3 minus 2, which is 1. And then let's do the millions place. That's 0 minus 9, which is not possible. We can't take away 9 from 0. So we borrow from this 1, which becomes 0. And then we add it to this digit, which becomes 10. 10 minus 9 now becomes 1. And there we have it. Our final answer is 1,180,789. See how quick and easy it is? Now you can add or subtract large numbers without taking too long. Now it's time for interesting fact time. Do you know that the different parts of an addition and subtraction operation have names? The numbers that are to be added together are called addends, and the result of their addition is called the sum. For subtraction, the number which is going to be reduced is called the minuend, and the number that is going to be removed from the minuend is called the subtrahend, and the result of the subtraction operation is called the difference. So here's an example of addition and subtraction operations with their labels. If we have an equation like 10 plus 15 is equal to 25, then the numbers we are adding are called addends, and the result of the addition is called the sum. So 10 and 15 are called addends, and 25 is called the sum. For subtraction operations, like 25 minus 10, which is equal to 15, the first number which we will subtract from is called the minuend, while the number that we are going to subtract from the minuend is called the subtrahend. The result of the subtraction is called the difference. So 25 is the minuend, 10, which is being subtracted from 25, is called the subtrahend, and the result of subtracting the subtrahend from the minuend is called the difference. Now let's review what we have learned. You can pause the video if you need more time to answer the questions. Let's begin. It is one of the fastest and easiest way to add or subtract numbers. That's the standard algorithm. The standard algorithm is one of the fastest and easiest way to add or subtract numbers. What do we call the numbers that we are adding together? They're called addends. Addends are what we call numbers that we are adding together. What do we call the result of the addition operation? It's called the sum. Sum is what we call the result of the addition operation. Blank is the number that will be reduced using subtraction. Minuend is the number that will be reduced using subtraction. Blank is the number that will be taken or subtracted from the minuend. The answer is subtrahend. Subtrahend is the number that will be taken or subtracted from the minuend. It is the result of subtracting the subtrahend from the minuend. The answer is difference. The difference is the result of subtracting the subtrahend from the minuend. Add the numbers below using the standard algorithm. The answer is 12,017. So how did we arrive at this answer? Let's have 10,978 plus 1,039. So 9 plus 8 is 17. Let's carry over 1. 7 plus 3 is 10 plus 1. That's 11. 9 plus 0 is 9 plus 1. That's 10. Carry over 1. 0 plus 1 is 1 plus 1. That's 2. Think of a blank digit as having 0. So 1 plus 0 is 1. And there we have the answer. Subtract the numbers below using the standard algorithm. The answer is 4,669. So how did we come up with this answer? Let's try to solve this problem using the standard algorithm. We have 7,005 minus 2,336. So 5 minus 6 is not possible. We borrow 1 from 0, but 0 can't lend us any. So we borrow 1 from the hundreds place, but the hundreds place has a digit of 0 and can't lend us any as well. So we borrow from the thousands place, which is 7. We borrow 1. It becomes 6. So we add that 1 to the hundreds place. So 0 becomes now 10. But we need to borrow 1 for the tens place, so 10 becomes 9, and 0 also becomes 10. But we need to borrow 1 for the ones place, so 10 also becomes 9, and 5 becomes 15. So now we can perform the subtraction operation. 15 minus 6 is 9. 9 minus 3 is 6. 9 minus 3, again, is 6 as well. And 6 minus 2 is 4. And there we have the answer, 4,669. And that's it for now. Remember to keep on practicing your math skills with our sample exercises and workbooks. See you then. Visit mathhelptutor.com to improve your math skills and your math test scores today. You can do this through your unlimited access to all our math lessons, practice quizzes, and workbooks. You can also schedule a one-on-one tutorial session with us today. Check out the links below this video to see how you can support us if you found this video helpful. Of course, don't forget to like, subscribe, and share this video and this channel to your friends and family who might need this. See you soon!